Hello, in this video, I am going to show how process engineers can use CSense to monitor assets or process health using multivariate fingerprints for early detection of problems. This is the CSense discrete and batch troubleshooter. Using this, I can connect to historical data in our historian, which I can use to create process fingerprint of good behavior to monitor the process and detect problems very early. As a process engineer, I can also provide operational context to CSense. For example, indicating the process outputs that reflect the performance of the process. All these targets in our case are temperature and some emissions, and the process input is the raw material quality, which we can't control, and hence it is a disturbance. And these are the various adjustable parameters which we have to manage to operate the process well. In this case, I can use CSense to visually select data which represents good, optimal, and stable process conditions by marking the data that represents good behavior of the process that I want to use to make a fingerprint of good behavior. Then I can use a multivariate machine learning model called principal component analysis to create a fingerprint by using only the data that we marked as good. The clusters here represent operating regions. You can see some outlier data here that I want to exclude. I can exclude them using the unbrushed region option. In this case, I end up with a model that represents a normal operating conditions. We can still see some outliers on the SPE plot and we can remove them using the unbrushed region option. You can see on this plot that the threshold of all data is below 10. We can use 10 as a threshold for square prediction error, which is an indication of how close to normal the process is. We can say that everything is normal if it is below 10, and if it is above 10, we want to create an alert stating that the process is abnormal. This model or process fingerprint can now be deployed and saved into CSense Architect. CSense Architect is a drag and drop environment where, as a process engineer, I can develop and test my analytics before deploying them into the CSense Runtime Manager to run permanently in production. Here, the fingerprint model is saved. I have configured a simple alert based on the distance to model or square prediction error, which is the indication of how far the process is from normal. Here I have set the upper limit as 10, so I can raise an alert when the process moves away from the normal limit. I can simulate this with the historical data. Here we can see that the simulated case where the process moves away and the blue line is distance to model which goes beyond 10, and I raise an alert. At the same time, it will not only detect that the process moved away from normal, but it can also tell me the causes, meaning which of these sensors around the process that are inputs into the model are the most abnormal. This model, when I am satisfied, that is detecting the conditions that are different, I can deploy into the CSense Runtime Manager to run permanently, where it will read all inputs in real time using OPC from control systems, and it can publish results in real time to external OPC systems like DCS and SCADA, and can alert on it and display them to the operators to act on. For example, this is the Matricon OPC client reading the alerts and causes that are being published by CSense. Here we can see that there are no alerts as there are no abnormalities. I can also see the rank list of causes being normal and close to 0. In this video, I showed how process engineers can use CSense to monitor assets or process health using multivariate fingerprints for early detection of problems. Thanks for watching.